You ask for a steel beam, and the machine hands you something that looks, well, exactly like steel. I mean, it has the matte gray finish, it has the weight, it even clinks when you drop it, so
Right.
you slot it into the bridge you're building. And you don't find out it's actually painted cardboard until, like, 3 weeks later, when you try to drive a heavy transport truck over it, and the entire structure just, it completely collapses into the river.
It's a disaster.
Total disaster. And today we are looking at exactly why this sort of structural collapse is happening inside our code bases right now. We are doing a deep dive into the... No, they really aren't. And our mission today is to take all of that raw data and build you, the listener, an exact step-by-step playbook to stop this AI-induced rework. Because as someone trying to stay ahead of the curve, you're constantly hearing that AI is, revolutionizing coding. But you might also be feeling the secret frustration when these tools actually slow you down.
And that frustration is incredibly urgent to address. Because we are facing this industry-wide crisis of what we're calling almost right code.
Almost right code.
Yeah. The data from Stack Overflow, it paints a very stark picture of a profession that has fundamentally altered its daily habits to include AI, but, and this is the key part, it hasn't updated its trust metrics to match that adoption.
Right.
We are seeing mass integration happening simultaneously with a total collapse in engineering confidence.
Okay, let's unpack this, because we need to validate that frustration with the hard numbers. The disconnect here is staggering. When you look at the headline stats from the 2025 survey, 84% of developers are using or planning to use AI tools in their development process.
84%.
Yeah, up from 76% last year. And over half, 51% of professional developers are using these tools every single day. I mean, it has officially become the new autocomplete.
It's just baked in.
Exactly. It's baked right into the muscle memory of writing software. But then
you turn to the sentiment analysis section of the survey,
yeah,
and the facade just drops completely.
it totally falls apart.
It does. Because more developers actively distrust the accuracy of AI tools than trust them. 46% of the industry actively distrusts the output they are getting.
46%. Almost half the industry thinks the machine is lying to them.
And that's a massive spike from 31% just the previous year.
Wow.
And you know those who highly trust the AI, the true believers.
Oh, this is the craziest stat.
It's a minuscule 3%.
3%, which means 97% of software engineers are operating with some baseline level of suspicion about the logic that's just appearing on their monitors.
Yeah. The overall positive sentiment for AI tools has just plummeted. I mean, it hovered comfortably over 70% during the peak hype cycle of, 2023 and 2024.
Sure, when everyone was just playing with it.
Right. But this year, it barely holds at 60%. We have officially exited the honeymoon phase, and we've just collided with reality.
Hard reality.
And to understand the mechanics of why trust is dropping so precipitously, we have to really unpack that almost right tax. The survey explicitly asked developers to rank their frustrations, right?
Yeah.
And 66%, so 2/3 of the entire global industry, pointed to AI solutions that are almost right but not quite as their single biggest pain point.
It's the painted cardboard beam. I mean, it compiles, it looks clean, maybe it even passes the initial surface level linter.
Yep.
But the logic is fundamentally hollow.
And the downstream effect of that almost right code is what triggers the second biggest frustration in the whole survey. 45% of developers say that debugging AI-generated code is significantly more time-consuming than just writing the logic from scratch in the first place.
Because you're hunting for a ghost.
Yeah.
You're looking for an error you didn't even make. And I found the Reddit discussions dissecting these numbers to be absolutely fascinating because they challenge the very premise of the adoption metrics themselves.
Oh, the self-selection bias argument.
Yes. A user named Matthew brought up this brilliant critique regarding the survey's methodology. They noted that the 2025 survey flow was just aggressively heavy on AI questions. It hit respondents with a wall of, do you use AI? How often? What are your prompts? What agents do you prefer?
And statistical self-selection bias is a crucial lens here. Because if you are an engineer who fundamentally rejects AI tools,
right?
Say perhaps you work in a highly secure defense environment, or you just, you prefer traditional documentation, and you encounter 4 consecutive pages of hyper-specific AI questions,
you're going to get annoyed.
The psychological friction becomes overwhelming. You are highly likely to just abandon the survey halfway through.
Which means your I don't use AI and I don't trust it vote never even gets recorded in the final tally.
Exactly. The Murphy's Law of survey design as that Reddit thread called it. And look, it doesn't imply any malicious manipulation by Stack Overflow. It's just a natural byproduct of designing a questionnaire around the hottest trend in the industry.
Sure.
But it implies something deeply significant for engineering leaders, that 84% adoption rate. It might be artificially inflated. The reality on the ground might be vastly more skeptical than a 46% distrust metric suggests.
And the anecdotes people share to illustrate that skepticism, they really highlight the mechanical limitations of large language models. There is this story from a user, Cranberry Sauce.
Oh, the Fedora setup.
Yes. They tried using an AI agent to configure a remote desktop setup on Fedora 42. And they reported that the AI hallucinated 90% of the configuration steps.
90%.
90. They pointed out that the moment you step off the heavily paved road of generic React or Next.js scaffolding, the AI just entirely loses the plot.
And that happens because we tend to anthropomorphize the tool.
Yeah.
We assume the AI has this underlying conceptual model of a Linux operating system.
Like it understands what an OS actually is.
Exactly. But it doesn't. It relies entirely on probabilistic token generation based on the density of its training data. Think about it. There are tens of millions of GitHub repositories containing React components.
Right.
So the statistical probability of predicting the correct next token for a React hook is astronomically high. But Fedora 42, that is a specific, recently updated environment with a much, much smaller footprint in the training corpus.
So when it tries to configure the audio server or the network manager, it doesn't actually know what dependencies Fedora uses. It just predicts strings that mathematically resemble Linux commands.
Yes.
It might hand you a sudo apt-get command because Ubuntu tutorials totally dominate the training data, and it completely ignores the fact that Fedora uses the DNF package manager.
And here's the dangerous part. It delivers that functionally broken command with absolute structural confidence.
Oh, totally. It formats the code block beautifully. It adds these helpful little comments explaining what the broken command supposedly does.
It's very polite about being entirely wrong.
It really is. It's the equivalent of hiring a wildly overconfident intern who just graduated. You ask them to run a complex financial risk assessment. They hand you back a beautifully bound report. The typography is gorgeous. The charts are perfectly aligned.
The executive summary uses all the right corporate buzzwords.
Exactly. And human nature dictates that when we see high-fidelity formatting, we drop our guard. We assume the underlying logic matches the surface polish. You don't manually audit the formulas hidden in the spreadsheet cells because it looks so professional.
Right.
Then, a week later, you discover a catastrophic rounding error on page 12 that completely invalidates the entire projection.
And finding a subtle error in someone else's complex, confident-looking logic consumes vastly more cognitive energy than just doing the math yourself in the first place.
Yeah.
You have to reverse engineer their misunderstanding before you can even begin to correct it. That cognitive drain, that exact feeling, that is the almost right tax.
But, sitting in the break room complaining about the intern doesn't ship the product. You can't just revoke the intern's badge and banish them from the building.
No, you really can't.
Because the board of directors is demanding we use this new intern. And frankly, sometimes they do format those basic charts incredibly fast, so we have to figure out how to manage them.
And that management challenge requires a fundamental philosophical pivot for engineering leaders. The internal editorial strategy notes we analyzed, they are absolutely definitive on this point. Engineering leaders must completely overhaul how AI is framed within their teams.
Okay.
It must be explicitly defined and treated as a junior pair programmer, and completely stripped of any infallible Oracle status.
I want to dig into the psychology of that specific label, because words matter. Why does calling it a junior pair programmer actually change the way a senior developer interacts with their IDE?
It calibrates the developer's cognitive posture.
What do you mean?
Well, when you query in Oracle, like a traditional search engine or a calculator, your default operational mode is passive consumption. You ask the calculator for the square root of 9,482, it gives you a number, and you just paste that number into your spreadsheet.
Right, you don't break out a piece of scratch paper and do long division to check the calculator's work.
You implicitly trust the Oracle's determinism.
Because calculators don't probabilistically guess, they execute fixed operations.
Exactly. But if you shift the paradigm, and the system is framed as a junior developer sitting right beside you, your default mode shifts from passive consumption to active skepticism. You inherently expect gaps in their knowledge.
You know they're going to mess up.
Right. You assume they might lack historical context about the code base. Therefore, your brain automatically engages its verification circuits before you approve their pull request.
That dynamic was perfectly illustrated by another Reddit user, lunchmeat317. They used an analogy outside of software engineering entirely, which I thought was great. They compared AI usage between a seasoned lawyer and a layperson.
Oh, this is a brilliant analogy.
Isn't it? In the hands of a veteran attorney, generative AI is a phenomenal tool for drafting a complex legal contract. The AI saves the lawyer 2 hours of typing standard clauses, but crucially, the lawyer possesses the deep foundational expertise to instantly scan that document, spot the hallucinated legal precedents, verify the citations, and adjust the nuanced language.
Right. The lawyer provides the structural verification that the machine completely lacks.
But for a layperson who has never been to law school, that exact same AI output is functionally toxic. I mean, they cannot verify a single clause. They wouldn't know a valid precedent from a completely fabricated one. So they are forced to treat the AI as an oracle, which exposes them to immense legal liability. And lunchmeat317 applied this directly to software. They said AI is only a net positive when the human operating it is fully capable of doing the work themselves from scratch.
And taking that analogy and overlaying it onto the Stack Overflow demographic data that reveals a deeply concerning vulnerability in the industry right now. Because the survey indicates that 35% of all respondents have been coding for less than 10 years.
Wow. Over a third of the workforce.
Yes. We have a massive cohort of developers who are still building their foundational mental models of software architecture.
Right.
So are those developers treating the AI as a junior pair programmer? Or are they defaulting to the Oracle mindset because they simply lack the 10 years of hard-won architectural experience required to verify the output?
If a junior engineer relies on an AI that hallucinates a microservice boundary or like a database schema, and they lack the pattern recognition to spot the flaw, that almost right structural defect gets committed straight to the main branch.
It goes right into production.
Wait, let me stop you there, though, because my instinct as a manager pushes back hard against this junior pair programmer mandate.
Okay, let's hear it.
If I issue a directive telling my highly compensated senior engineers that they must treat this AI like a junior developer, aren't I effectively asking them to spend their highly valuable time mentoring a machine?
I see where you're going.
Because when a human junior developer makes a mistake, the senior dev corrects them, explains the underlying principle, and the junior dev learns. 6 months later, they don't make that mistake again.
Right.
But an LLM's weights are frozen. It doesn't learn from a local correction in an IDE. It will make the exact same Fedora 42 dependency error tomorrow. So if my senior staff is trapped in an endless loop of correcting an amnesiac junior dev, how does this possibly increase our velocity?
And that pushback gets to the very heart of why a structured framework is absolutely mandatory. The objective of the junior pair programmer mindset is absolutely not to mentor the machine. The objective is to forcefully restrict the machine's blast radius. You are applying targeted scrutiny based on the specific risk profile of the task.
So we aren't trying to teach it. We are just triaging its output.
Exactly. Think about how you deploy human junior engineers. You do not hand a first-year developer the keys to architect the core payment processing pipeline.
No, never.
You isolate them in a lower-risk environment. You let them write unit tests for a schema that a senior architect already designed. You let them build the CSS for a UI component where failure is visual, not catastrophic. You scope their usage.
That connects perfectly to the actionable part of our deep dive. We've established the mental framework. The AI is an amnesiac junior dev. It requires relentless verification, and it generates an invisible tax when left unsupervised.
Yep.
Now, we need to translate that philosophy into a concrete step-by-step policy for engineering squads. So how do we build this?
The execution of this policy begins with step 1, the 48-hour audit. We are advocating that within the next 48 hours, engineering leadership must avoid the temptation to sit in a siloed conference room and draft some theoretical top-down manifesto on artificial intelligence.
Well, but he reads those anyway.
Nobody. Instead, they need to select 1 or 2 active squads and ask them a single, surgically precise question.
Which is, where do AI code suggestions most often cause rework for you?
Notice the deliberate framing of that question. It is not asking, do you find AI helpful? It is not asking for a generalized sentiment score. It is aggressively hunting for friction.
But why limit it to 48 hours, and why focus purely on rework instead of overall productivity?
Because theoretical AI guidelines inevitably fail when they collide with the reality of a legacy code base. Every single company has its own architectural idiosyncrasies,
Yeah.
its own accumulated technical debt, its own unique deployment pipelines. So by interrogating the developers directly about rework, you bypass all the hype and you audit the actual physical friction points in your specific environment. It exposes the areas where your engineering culture is suffering from fake acceleration.
Fake acceleration. I initially thought fake acceleration just meant writing bad code quickly, but looking at the data, it's a much more systemic illusion.
It is a profound organizational illusion.
Hmm.
Fake acceleration occurs when a development team feels this intense sense of forward momentum because the AI is spewing out hundreds of lines of code an hour. The individual developers are getting massive dopamine hits.
The pull requests are huge.
The repository commit history looks incredibly active. If a manager is just looking at lines of code generated, velocity looks unprecedented.
But the actual delivery of stable, bug-free features into production completely stalls out.
The velocity collapses during the integration and review phases. All that rapidly generated probabilistic code creates a massive bottleneck. Reviewers are overwhelmed by the sheer volume, which leads to superficial approvals,
Which leads to mysterious regressions.
which results in endless review churn. The team is burning massive amounts of calories sprinting on a treadmill.
A user named Stark and Robotic described this exact treadmill on Reddit. They vented about spending their entire workday locked in a hallucination loop. They would point out a logical error generated by the AI. The AI would enthusiastically agree, claim it had fixed the issue, and then spit out a new block of code that was entirely different but equally nonsensical.
Oh, the endless apology loop.
Yes. They described it as arguing with a parrot that has learned to recite programming syntax without possessing any semantic understanding of what the words actually mean.
And the generate, fail, apologize, regenerate, fail cycle. That is a known artifact of reinforcement learning from human feedback. The models are heavily weighted to sound helpful, agreeable, and confident, even when mathematically they are guessing blindly. The 48-hour audit is designed to map out exactly which tasks in your specific codebase trigger those infuriating loops.
The survey data regarding AI agents, the autonomous tools that attempt to chain tasks together rather than just autocomplete lines, that reveals a mind-blowing paradox that backs this up perfectly.
The agent numbers are wild.
They really are. 69% of developers utilizing AI agents claim the tools have increased their personal productivity. But only 17% believe those same agents have improved team collaboration.
Wow.
In fact, out of every metric tracked, collaboration was the lowest rated impact by a massive margin.
And that statistical divergence is the undeniable signature of fake acceleration.
It proves that AI makes the individual feel like a superhero, but it turns the team into a sluggish bureaucracy. I mean, you're sitting alone, you prompt the agent, and a whole microservice just appears. You feel incredibly fast.
Right.
But when you submit that microservice to your squad, and it has to interface with 3 other systems it doesn't truly understand, the entire squad has to stop what they're doing to untangle your mess. The individual sprints, but the squad drags a parachute.
Which necessitates step 2 of the framework. Once the 48-hour audit identifies the specific tasks causing that drag, the squad must codify a lean, unambiguous policy document, no more than 3 to 5 items. And it explicitly defines the do's and don'ts of AI usage.
We have to draw hard boundaries, like where do we officially unleash the AI and where do we absolutely ban it?
The do's should be heavily clustered around high-volume, low-complexity tasks. AI is exceptionally proficient at boilerplate code generation, test scaffolding for pre-existing functions, and simple, localized refactoring.
Another Reddit user summarized this perfectly. They said they don't trust AI for logic, but it is vastly faster to ask it to generate a specific Docker file and tweak it than to wade through search engine results looking for a template.
Exactly.
They called it a supercharged autocomplete. Writing the 50 lines of CSS and configuration just to get a basic UI component to render on the screen that isn't engineering, that's just toil.
Because boilerplate is deterministic, and it is heavily represented in the training data. Generating a Docker file for a standard Node.js application is exactly the kind of pattern-matching task LLMs excel at.
So if the boilerplate is the do, what is the absolute don't? Where is the red tape?
Human-designed solutions must remain strictly mandatory for 2 domains: core business logic, and security-sensitive architecture.
Okay.
The AI must never be allowed to autonomously architect the rules governing how your business generates revenue, handles compliance, or processes sensitive data.
I want to break down why business logic is such a uniquely hostile environment for an LLM. Because mathematically, logic is just logic, right? If the model can output a perfectly optimized binary search tree, why does it completely faceplant when asked to write the logic for calculating a promotional discount in a shopping cart?
Because business logic is rarely governed by pure mathematical efficiency. Business logic is the crystallization of human intent. It's layered over years of company history, legal constraints, and totally bizarre edge cases. And none of that context exists in the model's training data.
Ah, like the AI doesn't know that the shipping calculation module contains this highly inefficient, convoluted exception for 3 specific postal codes in Alaska.
Right.
Because, like, 4 years ago, the VP of sales made a handshake deal with a regional logistics vendor, and the company is still legally bound to honor that specific pricing tier.
Exactly. When the AI scans that Alaska shipping code, it doesn't see a legal obligation. It sees mathematical inefficiency.
It wants to clean it up.
It will confidently refactor that logic into something structurally cleaner. And doing so, it will silently break a binding corporate contract. It lacks the institutional memory required to understand why the code is ugly in the first place.
That makes so much sense.
And it's similar with security implementations. AI models are infamous for prioritizing execution over defense. If hard-coding a database credential or bypassing a sanitization check allows the function to successfully return a value and satisfy the prompt, the AI will routinely choose the insecure path just to get the job done.
I visualize it like constructing a commercial building. You can absolutely use automated machinery to mass produce the drywall, the 2x4s, the ceiling tiles. That's your boilerplate. It's repetitive. It's standardized.
Yep.
But you cannot let an autonomous machine pour the concrete foundation or design the high-voltage electrical schematic. The foundation is your core business logic. If the machine hallucinates the load-bearing calculations, the entire business collapses. And the electrical wiring is your security. If the machine wires it blindly just to get the lights to turn on, the building eventually burns down.
That separation of concerns, automating the toil while reserving human cognition for the structural foundation, that leads directly to step 3 of our framework.
Which is?
Once you have defined where AI is allowed to operate, you have to fundamentally change how you review the code it produces. Engineering teams must implement a 2-layer code review process.
This feels like the most critical intervention to stop the almost right tax from bankrupting a team's time. What does the first layer actually entail?
Layer 1 is uncompromising explicit labeling. Any code block that is primarily generated or heavily assisted by an AI tool must be clearly tagged as such when submitted for a pull request.
Okay.
A human reviewer must never, under any circumstances, be left guessing whether a human colleague thought through the logic or if a machine probabilistically generated it.
I can hear managers objecting to this right now, arguing that labeling code as AI might create this hostile review culture where senior devs unfairly target junior devs for using tools. Doesn't this just slow down the PR process?
Slowing down the PR process is the exact intended outcome.
Really?
Yes. We have to break the passive shortcut mindset. If a developer submits a 400-line pull request and the reviewer assumes the developer spent 2 days meticulously crafting it, the reviewer might just skim the logic and think, Sarah's a meticulous engineer. This looks syntactically clean.
They are trusting Sarah's human reputation.
Right. But if that same 400-line PR is flagged as AI generated, the reviewer's psychological posture snaps from passive trust to active defensive skepticism.
It's like an airlock system in a submarine. That first door, the labeling, ensures everyone knows they are stepping into a potentially hazardous environment. And that brings us to the second door of the airlock, Layer 2.
Layer 2 dictates that AI-generated code must be subjected to significantly stricter testing and code review standards than human-written code.
A user named Romeo Pentium made a brilliant tactical point about this on Reddit. They use both GitHub Copilot and Anthropic's Claude, but they flatly stated they never use them for logic where they can't instantly catch mistakes. They called the output sloppy, inconsistent, and non-deterministic.
Which is accurate.
But their core argument was that the software engineering industry is uniquely blessed with incredibly aggressive automated tools. Strict static analysis, aggressive linters, and comprehensive automated test suites. And Romeo Pentium argued that we must turn those existing tools into a weapon against AI hallucinations.
And that is the only viable defense mechanism against a probabilistic system. Because AI is inherently non-deterministic, meaning you can submit the exact same prompt twice and receive two entirely different architectural approaches. You cannot rely on human intuition alone to verify it.
Right, you need the math.
You must rely on merciless automated friction. If an AI writes a new function, the test coverage mandate for that specific function shouldn't be your standard 80%. It needs to be 100%. The static analysis tools need to be cranked up to their most pedantic, restrictive settings. You treat the generated code as inherently hostile until it mathematically proves its safety against your test suite.
But who is actually enforcing this? The Stack Overflow data reveals a fascinating dynamic regarding who actually trusts these tools, and it heavily correlates with experience.
The demographic crosstabs in the survey are illuminating here. The most experienced developers in the industry are the most intensely cautious. The data shows that veteran engineers have the lowest highly trust rate, a microscopic 2.6%.
2.6.
And the highest highly distrust rate, surging to 20%.
So the individuals who have been building systems for 2 decades, the ones who genuinely understand how complex microservices interact under load, they are looking at the AI output and issuing a hard rejection.
Because their brains possess the deeply ingrained pattern recognition necessary to spot the invisible structural fractures that junior developers simply cannot see. By enforcing a mandatory 2-layer review process, strict labeling, and hyper-aggressive automated testing, you are essentially taking the hard-won skeptical intuition of a 20-year principal engineer and operationalizing it as a mandatory workflow for the entire squad.
All right, we've audited the friction points, we've established hard boundaries protecting our business logic, and we've built the airlock for our code reviews. That brings us to step 4 of the framework, which deals with the sheer environmental chaos happening on developers' local machines. We have to address tool sprawl.
The editorial strategy notes flag tool sprawl as a massive hidden tax on cognitive load. The modern developer is currently context switching between 6 to 10 different platforms daily.
It's exhausting.
They have their IDE, their version control, Jira or Linear for issue tracking, a CI/CD pipeline, package managers. And now, organizations are layering multiple disparate AI chatbot windows and web agents on top of that already fragile ecosystem.
I remember the early pitch for AI coding assistants. The promise was consolidation. It was supposed to be the single conversational interface that abstracted away all the other tools. Instead, it just became tool number 11, demanding a slice of my RAM and my attention.
To contextualize this sprawl, look at the broader technology shifts captured in the survey. Python adoption saw a massive 7 percentage point explosion this year, reaching nearly 58%. After more than a decade of steady, incremental growth, it violently accelerated.
Why?
Because Python is the lingua franca of the AI revolution.
Right. Everyone is racing to integrate Python-backed AI wrappers into their workflow, but simultaneously, developers are showing they have zero tolerance for poorly implemented tools. The survey asked developers to rank the primary reasons they will abandon a technology. I initially assumed lack of AI features would be the death knell for a tool right now.
It was the exact opposite.
Literally the opposite.
The lack of AI features ranked 9th out of 10. It was nearly the least important factor in deciding to drop a tool. The absolute #1 deal-breaker ranking above prohibitive pricing and poor documentation was security and privacy concerns.
That is a massive signal to the market. Developers will uninstall your shiny new AI tool the second that they suspect it is phoning home and leaking their proprietary corporate data to train a public model. They care exponentially more about data sovereignty than they do about a chatbot writing their rejects.
We see this exact preference for stability and trust reflected in the dominance of traditional IDEs. Despite hundreds of millions of dollars in venture capital funding completely new, AI-native development environments, Visual Studio Code, remains an absolute monolith at 76% adoption.
Insane market share.
With Visual Studio behind it at 29%. They have held those top positions for 4 consecutive years.
Developers are violently rejecting the idea of abandoning their trusted environments. They want the AI to come to them as an extension, completely subservient to the workflow they already know.
Which defines the framework's solution to tool sprawl. Aggressive rationalization. Engineering leadership must collapse the tooling stack. You cannot allow Squad A to expense one AI startup's tool, while Squad B uses a different web-based agent.
No.
You must integrate a single, heavily vetted AI assistant directly into your primary IDE and your centralized code review platform. Keep the context switching to 0.
And it isn't just about picking one tool, it's about configuring it defensively. You have to lock down the telemetry at the organizational level to ensure privacy, and you have to scope the agent's permissions so it isn't trying to rewrite your entire database schema when a junior dev asks it how to center a div.
But true rationalization isn't just deleting redundant software. It is acknowledging the limits of automation and deliberately routing human problems back to human solutions. The survey data shows a fascinating resurgence in the need for human verification. Stack Overflow itself is increasingly being utilized as a trauma center for AI-induced bugs.
That stat blew my mind. 35% of developers explicitly state that their visits to Stack Overflow are a direct result of trying to untangle messes created by AI tools. And the volume of advanced architectural questions on the platform has doubled since 2023.
It perfectly illustrates the edge of the AI oracle's capability. When an AI fails, it doesn't fail with a simple syntax error. It fails by weaving a complex, deeply logical-sounding hallucination.
Right.
The resulting bug is often so esoteric and tangled that feeding the error back into the AI just makes the hallucination worse.
Yep.
You reach a point where you absolutely must find a human expert who has encountered that specific bizarre interaction in the wild.
So the policy framework must formalize that escape hatch. When a developer hits a complex, context-heavy problem, the exact scenario where AI confidently bluffs, the policy needs to explicitly dictate. Stop prompting the machine.
Yes.
Route this complex query to our central knowledge platform. Whether that is an internal engineering wiki, a verified documentation repository, or a trusted community platform, you have to redirect the engineer to where the human verified patterns actually live.
Relying on a probabilistic machine to debug another machine's hallucination is how you lose 3 days of engineering time to a single broken dependency.
The desire for deterministic reliability over probabilistic magic is screaming at us from the most admired technologies section of the survey. The single most admired technology across the entire 49,000-person dataset, boasting a 74% admiration rate, is UV.
A ridiculously fast Python package manager written in Rust.
Yes. And right behind it, the most admired cloud development tool at 71% is Cargo, which is Rust's build system. These are not flashy generative AI agents. These are structurally sound, relentlessly deterministic foundational tools. It proves that developers do not want a dozen mediocre AI tools throwing confetti on their screens. They want a tool that behaves like a high-quality, perfectly machined wrench.
Because a wrench doesn't guess. When you turn a high-quality wrench, the bolt tightens, doesn't strip the thread, paint it silver, and then confidently hallucinate that the structure is secure. Engineering leaders must build their entire tooling ecosystem around that demand for determinism.
We have covered an immense amount of ground today, tearing down the hype and looking at the raw mechanics of how software is actually being built right now. Let's recap the exact playbook we've constructed for engineering squads.
The framework requires 4 distinct actions. First, mandate the psychological shift. Treat the AI exclusively as a junior pair programmer, never as an oracle. Second, execute the 48-hour audit. Identify the specific tasks in your codebase that trigger hallucination loops and fake acceleration.
Third, establish strict boundaries. Unleash the AI on boilerplate and test scaffolding, but permanently ban it from autonomously touching core business logic or security infrastructure. Next, enforce the 2-layer code review. Require explicit labeling on all AI-generated PRs to shift reviewer psychology and deploy hyper-aggressive static analysis and testing to mathematically prove the code's safety.
And finally, rationalize the tool sprawl. Integrate a single AI tool directly into your trusted IDE, lock down the privacy telemetry, and explicitly route complex debugging out of the AI prompt window and back to human-verified knowledge bases.
Implementing this framework isn't about being a Luddite. It isn't about using less AI. It is about taking back control of your engineering culture. It is about eradicating the invisible tax that is draining your team's attention, eroding their trust in the codebase, and trapping them in endless debugging loops. It's about ensuring the machine works for you rather than your team working to fix the machine.
And as we look at the horizon, there is one final, rather chilling data point from the survey that every technical leader needs to internalize. When you look at the youngest demographic developers aged 18 to 24, they heavily prefer interactive formats, coding challenges, and AI tools to skill up. In fact, over 36% of all developers are now using AI specifically to learn how to code.
They aren't just using it to type faster. They're using it as their primary teacher.
Now, overlay that with the fact that software architect has risen to become the fourth most popular role in the entire industry. We are looking at a future where the next generation of architects is learning their craft primarily by prompting an AI and then debugging the almost right probabilistic hallucinations it spits back. They are not sitting in front of a blank screen, struggling through the agonizing but necessary cognitive process of designing a system from absolute scratch. Which begs the question, are we fundamentally degrading the human brain's ability to intuitively understand deep software architecture? If a developer never has to construct the foundational logic themselves, because their synthetic junior pair programmer always hands them a highly polished, heavily formatted first draft, will the senior technical leaders of 2035 even know what a structurally sound, elegantly integrated codebase looks like? Will they possess the mental models required to verify the blueprints? Or will our entire digital infrastructure just devolve into layers upon layers of slightly buggy, machine-generated approximations that nobody truly understands?
When the automated sensors fail and the blueprints are muddy, the survival of the bridge always comes down to the fundamental expertise of the human engineer standing in the mud. The tools, no matter how fast they generate text, are only ever as good as the mind verifying them. Stay sharp, verify everything, and we will catch you on the next deep dive.